We talk about blood all the time, but have you ever really stopped and thought about where it actually comes from? It's not just there, it's being made constantly. Deep inside your body, there's this incredible, non-stop factory running right this second. And today, we're going to take a tour. Okay, get this. Every single minute, your body is churning out over 150 million new red blood cells. No, that's not a typo. It's an assembly line on a scale that's almost impossible to imagine. So where is this massive factory, and who or what is in charge? Well, the answer has a pretty cool scientific name: hematopoiesis. It's happening right now, deep inside the marrow of your bones. And this one process is the key to how your body carries oxygen, fights off infections, and even heals from a simple cut. Every great factory needs raw materials, right? And to really get how this one works, we've got to go right to the source. We need to meet the single, remarkable cell that acts as the ancestor for every blood cell you've ever had. So what exactly is hematopoiesis? Think of it as your body's ultimate renewal program. It's running 24/7 to make sure that any blood cells that get old, worn out, or damaged are immediately swapped out for fresh new ones. The hero of this whole story is this tiny powerhouse cell, the hematopoietic stem cell, or HSC for short. Seriously, every single one of the trillions of blood cells in your body can trace its family tree right back to one of these original cells. Now, what makes these HSCs so special? Well, they've basically got two superpowers. First is self-renewal. It can make perfect copies of itself, which means you never run out. And second, and this is the real game changer, is multipotency. This is its incredible ability to become any type of blood cell the body needs whenever it needs it. Okay, so an HSC can become anything. But how does it decide what to become? This is where our factory tour gets really, really interesting. I mean, that's the big question, isn't it? How do you get oxygen carriers, infection fighters, and wound healers all from the exact same starting point? The answer is all about making a series of one-way decisions. And here we see the very first major fork in the road. The HSC commits. It decides to become either a myeloid or a lymphoid progenitor cell. You can think of these as the two main production lines in our factory. And here's the key. Once a cell starts down one of these paths, there's no turning back. It's the first step from being a jack of all trades to becoming a specialist. All right, so we've got our two main assembly lines up and running now, the myeloid and the lymphoid paths. Let's follow them to the end and check out the amazing variety of finished products they create. The myeloid line is all about your body's first responders, the cells you need for immediate action. It's cranking out red blood cells, those tireless couriers that deliver oxygen everywhere. It's making platelets, the little heroes that rush to plug up any cuts. And it's building the frontline soldiers of your immune system, like neutrophils and macrophages, that literally gobble up invading bacteria. So while the myeloid crew is handling all the day-to-day emergencies, the lymphoid branch is busy building something a lot more sophisticated. This is the body's intelligent defense system, its high-tech security force. And these guys, this is the elite unit. The lymphoid line produces B cells, which are like tiny weapons factories creating targeted antibodies. It makes T cells, the brilliant field commanders that coordinate the entire immune attack. And then you have natural killer cells. And yes, they are just as fearsome as they sound. They're the agents that identify and take out our own compromised body cells on the spot. So this is an incredibly complex system, right? With so many moving parts. It can't just be random. So who's the factory foreman? Who is sending out the orders to produce more of one cell and less of another? The way it's all controlled is actually super elegant. Your body sends out specific signaling molecules that act like urgent text messages. These messages travel directly to the bone marrow factory floor, telling the stem cells exactly which products are in high demand at that very moment. For instance, if you're low on oxygen after a hard workout, the body sends out a signal called EPO with a simple order: make more red blood cells, stat. If you get a cut, it sends a different signal, TPO, to ramp up platelet production. And if you're fighting an infection, a molecule called GCSF gets sent out to order more neutrophils. It is a perfect real-time supply and demand system. So this is a beautiful biological process for sure, but what's the real-world impact? Why is understanding this hidden factory so critically important for our health? Because when this production line breaks, the consequences are severe. If red blood cell production falters, you get anemia. If the white blood cell machinery goes haywire and starts producing cancerous cells, that's leukemia. Problems in the lymphoid lineage can lead to lymphoma. You see, many blood diseases are, at their core, problems with this factory. And this is where the story turns from problem to hope. Because by understanding the intricate blueprints of this factory, from the master stem cell all the way down to the final product, we also learn how to repair it. This knowledge is the very foundation of modern marvels like the bone marrow transplant. In essence, what is a transplant? It's like rebooting a faulty factory. Doctors can replace a patient's malfunctioning system with healthy stem cells, allowing their body to once again build a healthy blood and immune system from scratch. So when you step back and look at the big picture, it's truly breathtaking. This entire complex, perfectly regulated, life-sustaining universe of cells inside you begins with a single, humble ancestor and is completely rebuilt, day after day. And it leaves you with this final, powerful question. We've learned to fix the factory when it breaks, but as our understanding grows deeper, what comes next? Could we learn to fine-tune it, to enhance it? Could we use the secrets of hematopoiesis to push the very boundaries of what we consider a healthy life? The story is far from over.